Hello everyone, I'm Claire Lemoine from Grenoble INP FELMA, and last year I did an internship at CREATIS Laboratory, and I will tell you about MRI aftercare of the remyelination process in rats corpus callosum. So, what is remyelination? It is a process which happens in each safe people. And this process doesn't work by people who suffer from multiple sclerosis. Multiple sclerosis is an autoimmune, neurodegenerative, and inflammatory disease of the myelin. You can see the myelin in blue here, which is around the axons in neurons, and the higher concentration of neurons is in the brain, so we observe the higher concentration of myelin in the brain, and especially in the corpus callosum, which is the arc which is the link between right and left brain. Here is the human brain, and here a rat brain. So when people suffer from multiple sclerosis, there is a demyelination, and in the aftercare, we want to observe remyelination. To do this observation, we use MRI, and in a nutshell, MRI is the response of hydrogen by magnetization. So magnetization excited the hydrogen in molecules, and this molecule emits radiations, and we have T1 and T2, which are proper constants of the tissues, and help us to distinguish tissues with MRI. So myelin is composed by lipid and protein, so it is very rich with hydrogen, so that the T2 is very short. Here we can see a T2 of the rat brain, and we see that there isn't any contrast. So techniques were developed, and especially in CREATIS, they developed the optimal control to have contrast. And this optimal control is based on the T2 and also the T1. And here you can see optimal control where the corpus callosum is high signal, and here the corpus callosum is low signal. To observe remyelination, we had 31 rats were injected to simulate multiple sclerosis, and we make until 4 acquisitions. So some rats got only 1, other 2, other 3, and the rest 4 acquisitions. And after the last acquisition of each rat, they were sacrificed to get histological measure. And all measures were made at CREATIS in the pilot platform on an 11 Tesla MRI. So to observe remyelination, I developed a method of segmentation after pre-processing methods. First, MRI induces a bias because of the antenna of the MRI machine, and I corrected this. Then I make an adjustment in 3D of each MRI of each rat on one model rat. And then I normalized all intensities to have a comparable intensity in each date of each rat. So finally, I can segment with machine and deep learning the corpus callosum and get a corpus callosum, the gray matter around it, and also parcelize the corpus callosum to have details. So the results, we plot intensities in the corpus callosum and in the gray matter around it. And we observe that in generality, the intensities are higher in the damaged side of the corpus callosum than in the safe side. And we also observe that optimal control reveals a higher intensity to make differences, and also the fluctuations are very high in the optimal control, which shows that this modality is interesting to make an analysis of the myelin. And also, I plot in the time the profile of the corpus callosum in optimal control, high signal and low signal, to observe if intensity is correlated with remyelination. Apparently, there is an evolution, but it isn't monotone, so the conclusion were difficult. And this is based on normalization. To conclude with this subject, optimal control reveals to be very interesting to observe myelin because it offers more contrast between structures than simple T2 and more precision thanks to the fluctuations which were observed. But this fluctuation makes the segmentation difficult, and the longitudinal analysis requires a good normalization to have a similar intensity to compare between acquisition. For scoring, I will analyze the histological to compare with the MRI capture of last year. And thank you for your attention.